and my name is Jill Prince, and I'm an aerospace engineer with the Atmospheric Flight and Entry Systems branch here at NASA Langley Research Center. Now, I came to NASA as a graduate student in 1999. I had just finished a bachelor's degree in physics and astronomy from Northwestern University, and I came here for an aerospace engineering degree, a master's degree with George Washington University. It's a two-year program in which I took my classes with the university and did all my research with Langley engineers. So it was very hands-on and it was very interesting work. Some of the first projects that I was involved with, I jumped right into the deep end, and I worked a flight project, the Mars 2001 Odyssey orbiter. And what I did there was that I helped with the design and aerobraking operations. Now, aerobraking is the process of a spacecraft getting into a large elliptical orbit and using the atmosphere to slow down and slowly change the orbit from a large elliptical orbit to a small circular orbit so that this orbiter can do its science later on from a smaller orbit. Now, we do that by passing through the atmosphere hundreds and hundreds of times, and doing that is very risky and it's very tedious. You have to do that for many days, 3 to 6 months. And so I did that for the Mars Odyssey mission. Project since then, I worked the 2005 Mars Reconnaissance Orbiter, which also uses the aerobraking technique to change its orbit from a large elliptical to a smaller, closer to circular orbit. And then in 2007, I worked the Mars Phoenix lander problem. The Mars Phoenix lander was a very exciting mission, and what I worked on was the entry, descent, and landing phase. And there are lots of interesting things that go on during what we call the EDL phase. Everything from making sure the heat shield can withstand the heat of the Mars atmosphere, to deploying a parachute, to jettisoning that heat shield, getting rid of that parachute, opening its 3 legs, and employing the radar so it knows where to land on the surface of Mars. So lots of things happen between those 6 minutes that it gets from the top of the atmosphere to the surface of Mars. The most exciting thing about my job is that I get to send missions to or around Mars, which is very, very cool. Kind of knowing that you have a hand in something that will be there for generations to come, maybe even forever, is very, very exciting for me. And some of the lessons learned that I've applied to my job, anything, science and math is very, very important at a very early age, but I didn't know that I wanted to get into science and math until very late in the game, and so I'm not sure that that's as important to focus every aspect of your being into at very early on. I think it's very important to be very well-rounded. And in doing that, it's very important to develop the skills and develop teams to work together. And I think that's one of the main things that I've learned in my career is team building, working with people, and then some of the other things kind of go hand in hand with that, with persistence and perseverance and really getting into problem solving.